All right, greetings, scholars. Welcome. Hopefully, you all had a great weekend. Let me see. As far as announcements go, I'm still kind of working on midterm grades. It's just taking me longer than I originally anticipated. But once they are loaded, it's going to be based on everything that was due from the beginning through exam 2. Right. So exam 1 and 2 both were focused on chapter 1. So it'll just be based on that content. And the midterm grade is just a snapshot of where you are at that moment in time. It has no bearing on your final grade. It's just a gauge, and so if your midterm grade is lower than what you would like, I would encourage you to go back and improve the scores on some of your assignments. The system, you get unlimited attempts. The system is to take your highest score, and that technique will work as long as if you scored less than 90% on items. Also, if you are going back to redo assignments to boost your score, I would encourage you to prioritize your exams, where that's where you're going to get the most bang for your buck. And then you can prioritize the homework last, because that's where you're going to get the least bang for your buck. The homework is going to be a lot of work for minimal points. But if you want to maximize your impact or on your grade or the movement, you want to prioritize your exams. And again, this only works if you score less than 90% on an assignment, right? Because if something is submitted late, the highest you can earn is a 90. As usual, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. And I'll check attendance again in about 12 minutes. When we hit about 4:15, I'll do another pass. Let me check one more time before we get into the meat and potatoes. We are missing a good amount. Okay. Let's see. Okay, I'll let these gentlemen in. Okay. So welcome, gentlemen. If you're just joining us, we kind of just did announcements, and I was just kind of giving a spiel about the midterm grades. I'm just working on them. That was the long and short of that. If you want the exact thing, I am live streaming this on my YouTube, so you can always go back and watch that. So since we've completed exam 2, that officially ended chapter 1 for us, and so now we're moving into chapter 2. Okay. And so chapter 2 focuses on polynomials and rational functions. Our rhythm from here on out, we'll do pretty much 3 weeks of lecture, 1 week of testing, 3 weeks of lecture, and then I think we'll be at the final at that time, right? I know one of my students earlier asked, how many more exams do we have? And it's really 2 more exams. It should be exam 3 and then the final exam. I think that's how we have it set up. All right, so 3 weeks of lecture, 1 week of testing, 3 weeks of lecture, 1 week of testing. I think that gets us to the end. We still have our Thanksgiving break coming up, right? So more than likely on that week, we won't meet on that Wednesday, but we will meet on that Monday. And again, we're remote. So even if we do meet, as long as you log in, get your attendance credit, I'll be none the wiser of the rest of it. So if you wanted to leave early, you can, but it's still a good idea to make sure to get your attendance credit on that Monday. We can talk about that more as that time is closer. And again, I'll check attendance again at about the 15-minute mark. Okay, so in chapter 2, we're going to start with section 2.1, quadratic functions. A few objectives. 1, graph a quadratic function in standard form. 2, graph any quadratic function. 3, solve problems modeled by quadratic functions. So a quadratic function, a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0 is called a quadratic function, right? So we've kind of explored this already when we did the library of functions. This is similar to our squaring function, y equals x squared, which is a U-shaped curve. So these are all U-shaped curves as well, but we're gonna dive deeper into the U-shaped curves, the squaring function, more specifically with the quadratic, and just explore some concepts and techniques that come out of the discussion of quadratic functions. Okay. So then the standard form of a quadratic, what we saw before, I think, was the general form. No, that's not even the general form, because the general form is actually something else. This is just just a quadratic function, right? But then here we're going to look at the standard form of a quadratic function. The quadratic function f of x equals a times quantity x minus h squared plus k, where a is not equal to 0. We say this is in standard form. The graph of f is a parabola with the vertex h comma k. The parabola is symmetric with respect to the line x equals h, called the axis of the parabola. If a is positive, the parabola opens up, and if a is negative, the parabola opens downward, right? So similar to like our discussion of lines, where whenever we have a line in slope-intercept form, i.e. y equals mx plus b, to me, that's the easiest way to graph a line because you get so much information from that form. This is analogous to that, where I feel like this is the easiest way to graph a quadratic when it's in standard form, because it in this form, we automatically get the coordinates of the vertex, right? If our a is positive, if the leading coefficient is positive, then that means our quadratic opens upward and we're going to have a minimum value, right, at the vertex. If our a is negative, that means our parabola opens downward and we're going to have a maximum value at the vertex, right? And then we also automatically get our axis of symmetry is going to be x equals whatever our h is, okay? So here we're asked to find the standard form of a quadratic function whose graph has the vertex negative 3, 4 and passes through this point, right? Okay. Okay, so the standard form of a quadratic. So if you have a formula sheet, this is a good formula to update your formula sheet with. Let me see, the standard form of a quadratic takes on the form f of x equals a times x minus h squared plus k. Let me mark these other gentlemen as absent for now. Okay. All right, and then we're given, so if the vertex is negative 3, 4, that means our h is negative 3 and our k is 4. And if we wanted to pass through the point negative 4, 7, that means this serves as our x value and this serves as our y value. Let's plug these different components in and see how this unfolds. We don't have any information on a, so I'm just going to bring that down. And with each component, I'm going to replace each component with a blank set of parentheses. Right. So we have x minus h squared plus k equals y. Okay, let's plug in. So our x is negative 4. Okay. Our h is negative 3. Notice how the parentheses help us to keep track of our signs. Our k is 4. Our y is 7. At this point, we have one equation, one unknown, so we can solve. Right? Notice here we have a double negative, right? So that becomes a positive 3. Negative 4 plus 3 is negative 1. Squared gives us positive 1. Times a gives us a, right? So that first term collapses all the way down to just a plus 4 equals 7. If we subtract 4 on both sides, a equals 3. Okay. So then our function ends up being 3 times x minus our h. Now, if we say x minus a negative 3, again, double negative becomes positive, so that becomes x plus 3 squared plus our k, which is 4. Okay, so 3 times x plus 3 squared plus 4. We lost a. Okay, let me just back up. This one. So then 3 times x plus 3 squared plus 4. Okay. Here we're asked to sketch the graph of this quadratic. Now notice that this quadratic is already in standard form, right? So because it's already in standard form, that gives us a lot of information. We know the coordinates of the vertex, which is going to be our h comma k. Now notice they have x plus 2, but in standard form, it takes on the form of x minus h. So we really should rewrite that as x minus negative 2, and that makes our h be negative 2. And then our k is going to be 12. So then if these are the coordinates of our vertex, our axis of symmetry is going to be x equals the x coordinate of our vertex, which is going to be -2. And then notice that our leading coefficient, which is our a, is -3. Notice that that's less than 0. So because our leading coefficient is negative, that means our parabola opens downward. If our vertex is -2, 12, that puts us in quadrant 2 and it opens downward. So we're kind of focused on quadrant 2. So what I'm going to do, a text box, space, paper, graph paper. All right, I'm going to introduce a mini graph paper. Okay. And since we're focused on quadrant 2, I'm going to put my origin, I think about here should be good. Let me copy, I'm going to paste that right there to use later. And so a positive x is going to go in this direction. Okay. A positive y goes in this direction. Okay. Again, this is my positive x. This is my positive y. So we're graphing -2, 12. So let me see. I know on my y-axis, let me see. 2, 4, 6, 8, 10, 12. Okay, that looks good there. 2, 4, 6. And then my x-axis, I just need to get to -2. 1, 2, 1, 2, 3, 4, 5, 6. I think that's pretty good. So here's our origin. This was 1, 2. This went by 1s, 4, 5, 6. And then on the y-axis, we went by 2s, 2, 4, 6, 8, 10, 12, 14, 2, 4, 6. And these are our negatives. Negative. Okay. Okay, so our vertex, I'll do it in green. As a matter of fact, style, green, copy. Okay, so we said -2, 12. And one other thing I like to do, let's go paper. I like to graph on the dots. Oh no, go back there. I think we're okay. Okay, so -2, 12 puts us right about there. Okay. Do this real quick, paper. I'm gonna turn this off. So then what this does, that's our vertex. That also gives us our axis of symmetry. So I'm going to go ahead and graph the axis of symmetry. Just give me a moment to kind of. There's that one. There's that one. That looks good. Let's go style. Come on. Thank you. Like this, a little bit thicker. That's too thick. All right, there is good, right? Okay. Let me label some of these items. So this is the ordered pair -2, 12. Our axis of symmetry is x equals -2. Okay. So then once we have the axis of the parabola, we can, whenever we get a point on one side, we automatically get a point on the other side, right? So for instance, when x is 0, right? 0 plus 2 is 2, squared is 4, times -3 is -12, plus 12 is 0, right? So when x is 0, y is 0. Okay. So then notice that when we went 2 to the right, we were at 0. So then that means that when we go 2 to the left, we should also be at 0. Honestly, that's enough. Let me see when x is 1. If I let x be 1, I think we go off the chart. That's a 3 squared is 9 times 3 is like a negative 27 plus 12 is a negative 15. Yeah, so we just need to go off the chart before we reach 1 and before we reach negative 5. Okay. So then if we connect these with a smooth curve, man, I cannot, my smooth curves are not working today. Let me try that again. That's like, let me see if I go like this. I don't know why I've been struggling all day. My graphs. Let's see, I can't see that one. Try like this. That's good enough. Let me try one other thing. So another technique I could do is like this, like that, finish there. Okay, let's see if I can get this to work. I think it's about there. That looks good. So very close. Yeah, this is why I don't use this technique, because it's okay. That kind of did it. Oh, that works for me. Okay. Finally got it to work. I've been trying to do that all day and I could not get it to work. That was the first time I got it to work all day. Oops, let's clean it up. All right, cool. Boom. Boom shakalaka. That's where there's a will, there's a way. Okay. And then let me just kind of reposition this, distort it a little bit, just to get a better image. Go about like there. Okay. So when we did it by hand, this is the result that we got. Let me kind of wrap up this example and I'll check on the attendance. Cancel. I believe in you. Cancel. Thank you. Right. Okay, so when we did it by hand, we got an image like this. So again, the parabola was given to us in standard form, so we can quickly identify our A and our H and our K. I think they got all the same things that we did. Fast forward, we got the same image. Okay. So we'll talk about this in just a moment. Let me check on Zoom. Guys, a Zoom again. Student. Let's see, right here. Okay, not bad. We're still missing 2. Okay. All right. So in the previous example, again, our quadratic was given to us in standard form. So now in this example, it's given to us not in standard form, right? So we have 2 different ways that we can go about this. I'm going to start off by showing you what I consider to be the more challenging technique, right? So with this being College Algebra 1, we do expect you all to have some level of proficiency when it comes to factoring. That's where our lab, like I know you all have the lab, so that's where, if you're not confident in factoring, it should come up in the lab. If you want some practice on factoring, I can point you and show you where I have like some work with like explanations if you want to practice on factoring. Long story short, if we go to Blackboard and we open up that box link the same way, similar to how you would access the notes. Well, instead of clicking open up the folder that says notes, open up the folder. If you go down a couple of folders, you'll see one that says handouts. And in the handouts folder, you should find a chapter devoted entirely to factoring. It's presented in 2 different ways. There's a flyer, there's a handout, a one sheet PDF that kind of summarizes all the different factoring scenarios. And then the second document is going to be basically a scan of an entire chapter devoted to factoring. So it'll showcase all the different scenarios with techniques and give you practice. But that's located in Blackboard right now. Okay. It should be. I usually make that part of my groups or whatever. So with this one, we want to use the factoring technique of completing the square to change it from this form into the standard form. Right now, as I say the phrase completing the square, if for whatever reason you're not like confident in doing that technique off the rip, which most students are not, because when else are you going to use completing the square other than like this kind of setting? I would encourage you to just do a YouTube search and watch a few presentations on how to complete the square. I'm going to do a live presentation here and now, showcasing completing the square, but it always helps with that to just see it from multiple perspectives, multiple angles, multiple people's kind of saying similar things, right? So let's start by doing this showcase on completing the square. Again, it's a factoring technique. And to change this equation into the standard form, okay? So first I'm going to start by getting a copy of the original. So we're starting with f of x equals 2x squared plus 8x minus 10, okay? Now the first thing whenever we do completing the square is we need to get that leading coefficient to be a 1. There are a couple of ways to go about it. I'm just going to start with 1. So in order to get that leading coefficient, namely this 2, in order to get that to be a 1, what I'm going to do is factor out 2 from all the terms. If you watch a few presentations on completing the square, other people might do it slightly different, and more than likely those are correct as well, right? I'm just choosing one route. So I'm going to, well, actually, with my students earlier, I factored out 2 from all the terms. I'm going to do it a little bit different for you all, just for my own sake, peace of mind to, and I actually did it earlier, but I'm going to change it up a little bit. If you want to see this done, if you want to see me do it a different way, you can watch the one, if this is a 4 o'clock, the 3 o'clock presentation was good. 3 o'clock or 2 o'clock from today. And you can see it done a different way, right? So instead of factoring out 2 from all 3 terms, I'm only going to factor out 2 from the first 2 terms, okay? So if I factor out 2, I'm going to kind of move over here to give myself some space. So then the first 2 terms are going to become x squared plus 4x. I'm going to leave some space, and then the minus 10 persists over here, okay? So now completing the square, the completing the square step is here. Basically, completing the square, we do, we're adding 0 in the form of plus b over 2 squared minus b over 2 squared, right? Because if we add 0, we don't change our answer. We're just changing the form into something that we can use, right? So we're going to say plus b over 2 squared and minus b over 2 squared, right? So we're adding 0 into that form. So then this is going to be plus 4 over 2 squared and minus 4 over 2 squared, okay? So then if we account for these changes, we get x squared plus 4x. 4 divided by 2 is 2, squared is 4, so that's going to be plus 4 minus 4, right? We're just adding 0, so we're not changing the answer, we're just changing the form, okay? So now in this form, what I want to do is group those first 3 terms together. If we focus on those first, I'm going to separate it with this vertical green bar. If we focus on those first 3 terms, then those guys factor into the following. Oops. So the 2 kind of persists. Those first 3 factor into x plus 2 squared, right? We still have this minus 4 here. Okay, minus 10. Now, if we want to move this minus 4 outside the parentheses, we need to multiply it by 2, right? That 2 in the front. Or in other words, what we need to do is distribute this 2 and multiply it by each term, right? And it takes practice to do this correctly. So then ultimately when we do this, we're going to get 2 times x plus 2 quantity squared. 2 times negative 4 is negative 8. -8 plus -10 is -18. Okay. So then this should be our original f of x in standard form. Okay. Notice if we use the equation on the right-hand side, when we let x be 0, we get a result of -10. If we plug 0 into what we just got, 0 plus 2 is 2, squared is 4, times 2 is 8. 8 minus 18 is -10, which is the result that we wanted. The reason I discouraged you from like watching, you can watch it, I left it on there. But this morning with the 9 o'clock class, I got to the same spot, and then for some reason I kept thinking, well, I'm supposed to get 0 when I plug in 0. So I had the right thing, but I was interpreting my results incorrectly. So I ate up like a good amount of time, like 5 or 10 minutes, trying to figure out what I was doing wrong. I don't know. I was not like, my mind wasn't clear or whatever. So, but when I checked it, I realized that what I had was correct, and then I realized that I was just interpreting my results incorrectly. So we got to the bottom. But yeah, so this is, and again, I did it one way here. If you want to see a different presentation, you can watch. I would encourage you to watch either the 2 o'clock or the 3 o'clock from today. So I did it here differently, but I got the same result, right? And I did that so that way, you know, just to break up the monotony for myself, and then if you use those recordings, you have a more complete sense. Okay, let's see. So now, if this is the quadratic in standard form, this gives us a lot of information about our quadratic, right? Remember the general form of the standard form is x minus h, right? So the coordinates of our vertex are h comma k. Or h, if that's x plus 2, we need to rewrite it as x minus a -2. So it's going to be -2 comma -18. Those are the coordinates of our vertex. And then our a, which is a +2, notice that's greater than 0. So that means our parabola opens upward. And the equation of our axis of the parabola is going to be x equals -2. Okay. So then we have plenty of information to graph this quadratic. Let me check on you guys in Zoom real quick. Okay, you guys are looking good. Okay, so our vertex is -2, -18. That puts us in quadrant 3. Our leading coefficient is positive, so our parabola opens up. So it looks like we're kind of focused on quadrant 3. Let me see. Nice, I can still use this. Let's change it to negro. Oh, and let's introduce some graph paper. Space, cool. Come on, you can do it. Oh no, no. All right, let's just try this again. There we go. Thank you. Paper, graph paper. All right. Okay, that's that. All right. So if we're focused on, we said quadrant 3. So I'm going to put my origin about here. Let's go here. All right. So then with that, positive x is going in this direction. Positive y is going in this direction. So just move this just a little bit. That looks better, okay. On the x-axis, so let's do the y since we're going to 18, -18. Let me see. 2, 4, 6, 8, 10, 12, 14, 16. So I gotta go up a little bit. Oh. What? I didn't want that either. I just want that and that. Yeah, that's exactly what I want. I think right there is good. Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. And then x-axis, we need 2, Let me see. We'll go 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay. So here's our origin. On the x-axis, this is our positive x, this is our positive y. We went by 1, so this is 1, 2, 3, 2, 3, 4, 5, 6, 7. Okay. On the y-axis, we went by 2, so this is a 2, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18. These guys are all negative. Okay, and this is negative. Okay, all right, that's good enough. So let's paste. Yes, green is good. -2, -18. Oh, and then do paper. I like to graph on this guy. Oh. Okay. -2, -18 is like here. Okay. So then that also gives us our axis of symmetry. It's a little bit quicker. It's kind of irking me. It's not locking like it normally does. Okay, and then let's go style. Change that to 4 and dash. That looks good. Let's label. Let me see. We got -2, -18. This is the axis x equals -2. Okay. Let's see. When x is 0. Am I repeating? Is this a repeat? No, it's not. Let's keep going. When x is 0, the corresponding y is -10. So notice when we went 2 to the right of the axis, we were at -10. So when we go 2 to the left of the axis, we should also be at -10 right here. There's 1 and 2 is there. Okay. Let's see. Let's do when x is 1. When x is 1, that's a 10 minus, it's like we're at 0, right? When x is 1, it looks like the corresponding y is 0. So when we went 3 to the right, we were at 0. So then when we go 3 to the left, we should also be at 0. So 1, 2, 3 is here. So we happen to find our x-intercepts, our y-intercepts. Now, if I were finding the intercepts like exclusively, I personally like to find my y-intercept first. I find that finding a y-intercept oftentimes is easier to do than finding the x-intercept. For instance, to find a y-intercept here, we set x equal to 0, right? So then you see those first two terms just cancel, they go to 0, and then we're left with -10, easy. But then to find the x-intercept, oftentimes we have to do like factoring and this other stuff. So that's like where we set y equal to 0. If we set y to 0, then we have to do factoring and a little bit of others, but we'll get these results. Okay. I'm going to assume that it goes, let me see. It was 8 and 16, puts it at 24. So 14, so it goes way off the chart before it reaches 2. So then if we connect these with the smooth curve, I'm going to try that same thing I did before, see if I can get the thing to work again. And I should go up right about there. Okay. So let's try that there. Oh. All right, we're gonna go with that. Oh, that works for me. Oh, I'm getting 2 for 2, right? I know. I'm excited because again, I was trying to do this earlier in the day. I could not get it to work, and now I'm getting it to work. But I'm seeing what I'm doing a little bit different as far as my technique. Let's see if I can try to get this to match right there. Yeah, that's decent. position U. And it should be good. Yeah, that looks good. Okay. So then again, we do an arrow to say continue the pattern in that direction and in that direction. Let me remove these lines, paper, and I'm going to shrink this down just some. Okay. Let's see. I'm going to put it about right there. Okay. So when we did it by hand, we got a result like this. Yay, that's so much better. Okay. Let's see. Okay. Let me go seamless and then switch it back to single page. Come on. Thank you. Nice. Let's leave you for now. Okay. Actually, let's go like this. Okay. Oh. Okay. So we saw a showcase again using completing the square to transform the original equation into the standard form. Another technique that we could have done, I guess I'll do it in orange. We could use this thing called the vertex formula. And basically, given a quadratic, you can use the vertex formula to jump to directly find the coordinates of the vertex, right? So H being the x coordinate of the vertex, you can find that by doing negative b over 2a. All right, let me just clean it up a little bit. All right, negative b over 2a. And that'll give you the x coordinate of the vertex. And then to find the y coordinate of the vertex, that's going to be our k, and that's going to be equal to f of h. So whatever answer you get from h, you pass it to the function to generate your k. And so if you, in this case, like for instance, our b is 8 and our a is 2. So if we had negative 8 divided by 4, we get negative 2. That's the same h that we got. So negative 2. And then once you pass negative 2 through the function, you'll get negative 18. So then once you have the coordinates at the vertex, then that means you can identify the axis of symmetry, choose a point on the right, find the corresponding, choose an x on one side, find the corresponding y, and then that automatically gives you a point on the other side of the axis of the parabola, right? And then also maybe it's a good idea to find like your x-intercepts, your y-intercept, and then put all that together and you get something like this. Easy, right? It's so simple. It's not that simple. But so one chart I saw, like when I was a student at Morehouse, they had it up on the walls. It basically said there is no such thing as complex. The things that we consider to be complex are just a long string of simple ideas, right? So, you know, when we get overwhelmed as humans, when we feel like something is complicated, that's just because we don't understand all the simple components, right? So what we have to do a lot of times is slow down and break apart the task into digestible pieces for you, right? What's digestible for you is not necessarily is not necessarily the same as what's digestible for me, right? So you have to like slow down and get intimate with the information and break it apart into something that you can digest. And so when you're able to take these like systems or the whole picture and break it apart into the simple components, then that's what we consider to be complex. Again, the things that we consider to be complex is really just a long string of simple ideas. If you say this simple idea plus that one plus this one plus this one plus that, we consider that to be complex, right? And I kind of went into that because, you know, this weekend was it's not her birthday, but we were celebrating her birthday, a friend of mine's birthday this weekend. So we found ourselves like at a paint and sip, and it was cool. And she was kind of getting a little bit frustrated with the work. I was like, wait a minute, you know, you don't have this is art, right? There's no right or wrong. It's just an expression, right? It's color. And so like she was trying to like make the shapes, and I was like, I was basically saying the same thing. You got to break it down into a simple shape. Like if you're drawing or trying to mimic something, you might start with like a circle. You might do your line of symmetry. Like we were painting trees, you know, and then basically all the guy did for the tree, first he did a black horizontal line across the middle of the canvas for like the horizon or whatever. And then with the tree, he started with a vertical line, and he connected it. And then he started at the top of the tree and he just started like making zigzags, but he made the zigzag get wider and wider and wider the further down you go. So when you're at the top, it's a small zigzag. And then by the time you get to the bottom, it kind of has like this whole Christmas tree pattern. But it was, again, just basically using basic shapes. We made a moon, but the basic shape there was a circle. So they gave us a paper plate to trace out the circle. We had a drawing competition that I actually surprisingly won. I wasn't planning on winning, but he was like, yeah, we're going to play a game. It's a drawing contest. And so he was like, he gave all the groups like another paper plate. He was like, okay, we're going to take a few minutes and each person's going to draw their partner, you know, and we're just going to have a quick competition. And so I was like, yo, just send me a photo of you and I'll start drawing. And she was like trying to argue with me. I was like, look, just send me a photo. Like, I'm not trying to go, like, just make it real simple and easy. So she's like, okay. So she sent me a photo and I just set it on my phone to the side and I just started drawing. But again, I did the same thing. Broke it down into the basic simple shapes. I did a circle, the axis of symmetry. I drew a horizontal axis for the eyes, for the mouth. So then I knew where to position the ears and I knew where to position the different features. Then once you have those lines of symmetry, you come back with like a light silhouette. And he gave us a pen so we couldn't erase. So I was going to do like this sketchy thing. Then I went back and added eyes, nose, ears, mouth. And somehow I actually won. I was like, what? I was like, okay. So that was a fun little competition, right? So we got like a solid 2 minutes. And this is about where I stopped with everyone else. So, the moral of the story, when you have a goal or something that you're trying to do, and there's actually a TED Talk on this. Like I can link you to the TED Talk if you want to see it. But this guy was talking about how to achieve any goal that you want. And the moral that he was saying was basically the same things that we just said a moment ago. When you have this goal, you break it into small digestible pieces. And as long as you consistently accomplish or complete those small digestible pieces, as long as you keep going, you will achieve your goal. Mind blowing. I use it in mathematics. I use it in art. I use it in gaming. I use it all over the place. I didn't even realize that that's what I was doing until he said it. I was like, dang, I've been doing that the whole time. Right. So anyway, so we did this by hand. We got that result. And I'm just fast forwarding. I just want to show you, they got the same image we got. It's a little distorted because our windows are different, but we got the same thing. Let me mention something quickly here. So for part A, the axis defines the domain and range of this image. The domain of an image like this is the very left to the very right. All right. So the very left to the very right is going to be all reals, negative infinity to infinity. And then the range is the very bottom to the very top, right? So the very bottom in this case is going to be negative infinity, but the highest that our graph goes is y equals 3. So then the range here will be negative infinity to 3. Because the graph actually touches 3, the 3 will get a square bracket. I see the time. Give me just a moment. I'm about to get you guys out of here. Okay. And then... So again, domain is the very left to the very right. Also, another way to visualize the domain, if we took our image and smushed it onto the x-axis, the domain is going to be all those different values of x that our smush graph touches. For the range, if we took our image and smushed it onto the y-axis, all those points that get touched is our range. Again, that's the very bottom to the very top. And then part B asks us to solve the inequality. It's asking us when is the function positive, or in other words, when is it above the x-axis? So we can actually just look at the image. It's above. I see the time. Give me just a moment. I'm trying to get people out. Give me just a moment. The quadratic is positive between the x-intercepts. So for that one, we would just, because they gave us the x-intercept, so we would say it's positive. Basically, as x goes from the left x-intercept to the right one, and those would get square brackets, and you see it here. And then this last one I'm gonna leave as an exercise for you all. I know someone just had a question, comment, or concern. I don't know if it got resolved.
Yeah. Can I talk to you after class for a second?
No. I'm kidding. Yes, of course.
Okay.
Any other questions, comments, or concerns before I let you all go? Going once, going twice. Okay. Let me see. As a quick recap. So When it comes to midterm grades, I'm still working on them. They should be completed by the end of the week, and I'll get them in there. Again, the midterm has no bearing on your final grade. It's really just a snapshot of where you are at this moment in time. I'm going to base the midterm grade on all assignments from the beginning through exam 2. So that's pretty much the assignments focused on chapter 1. And I think that's it. Again, if there are any other burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. We'll meet again on Wednesday, same time, same place. Take care, guys. Peace.
I wanted to ask, are you able to give me the what is it called? Give me the information for the I keep forgetting their names. Can you give me the names for the I just had it.
It's okay. It'll come. Hang on.
Give it a moment. Head of the math department and the Dr.
Oh, the bookstore?
Yeah. Because I couldn't figure out their names. I didn't want to be rude. I waited till the next class for that.
That's something you can like just search it. Like if you go to Google, you can do it directly from Google, like mathematics department chair at Morehouse, and that'll pop up. But I can I'm trying to think. Let me stop the live stream and then I'll just tell it to you. Give me just a moment.
Okay.
Wait, let me check one other thing. Give me just a moment. Is this Mr. Franklin?